Okay, this is video 204 or 204, and this is chapter 2, section 4, and we'll be talking about chemical reactions and enzymes. So what exactly is a chemical reaction? Well, it's a process that will change one set of atoms or chemicals or compounds into another set of atoms, chemicals, or compounds. Well, not different atoms, but it can combine the atoms or it can break the atoms apart. Now, during this process, mass and energy are conserved, if you remember your law of conservation of mass and your law of conservation of energy. So, as I said, during this process, bonds are made and bonds are broken. Now, the elements that you have, or the compounds that start the reaction in the beginning, are known as your reactants. Okay? And these reactants are either going to combine or break apart, and they're the ones, their valence electrons are going to do some type of rearranging, and then they will be known as products. So in this, at the very basic sense, you have reactants, yield, you can say yield, or produce products. Now another way you can write this a very simple reaction would be A plus B yields A and B, right? Now, in your body, the reason why we have to learn about chemical reactions in the human body is because these reactions are occurring all the time. It's a reaction for you to breathe. It's a reaction for you to think. It's a reaction for you to walk. All of those things require chemical reactions to occur. Now, one important one that occurs is the release of carbon dioxide when you exhale. So when you exhale and inhale, there's the chemical reactions that are occurring. Now, in your body, you will have a buildup of carbon dioxide. This carbon dioxide is one of the products of cellular respiration. Carbon dioxide is due to the breakdown of the glucose molecule, and it's in your tissues, and it needs to be excreted from your body. So what happens in your body is that this carbon dioxide combines with water very easily, okay? And it produces what's called carbonic acid. See this H2CO3 down here? That is carbonic acid. Okay? Carbonic acid. Now this carbonic acid can break apart, or that reaction can be reversed, and the carbon dioxide gas, so here we go. The carbon dioxide is picked up from your tissues and it goes into your capillaries where it combines with water. It then forms carbonic acid. The carbonic acid then has a reaction where it can break apart. The H2O stays in your blood, and then the carbon dioxide diffuses across to your lungs, and then you exhale it. Now, obviously, if there's a buildup of carbonic acid in your blood, we don't want that, and your pH would get too low, and then you could start feeling sick. So this reaction has to occur, and in order for the carbon dioxide to be released. So during these reactions, there's energy changes, and there always has to be enough energy for a chemical reaction to occur. So energy is either going to be released or absorbed when chemical bonds are formed or broken. Now, if energy is released, that is called an exothermic reaction. You may remember this from 8th grade. And then if energy is absorbed, do you remember that one? That's right, it's an endothermic reaction. Now, these energy changes is one of the things that has to occur in order for your reaction to occur. So, chemical reactions that release energy usually occur spontaneously, meaning that they will just happen on their own. And so normally think of things that explode or things that catch on fire. Those would be exothermic reactions that release energy. Now, the ones that absorb usually will not occur unless there's a source of energy. So usually you might have to heat it up or something like that in order, or apply some type of energy in order for it to occur. So an example of an energy releasing reaction is the burning of hydrogen gas Okay, so you have hydrogen, you have water, oxygen has to be present, and it produces water. And then the energy that's released will usually be heat or an explosion. Like I said, it could be light, it could be sound, or light and sound, not light or sound. So in the above reaction, the reactants would be on the left here. That's your water and your oxygen. Sorry about that. Reactants. And then this would be your product. Okay. Now this reverse reaction can also occur. Now in this case you have to apply energy to it, because remember, if energy is absorbed, it's not going to just happen spontaneously. And the way this could happen is through a process called electrolysis. Electrolysis. You're using electricity to break apart. Remember the other day in class I said lysis means to break apart. Synthesis is to bring together. Well, you can do this with electrolysis, and this is the setup. Sometimes in physical science, chemistry, no, maybe physics, you might do this electrolysis reaction. So every organism must have a source of energy, and we talked about energy and metabolism when we talked about the characteristics of life, remember? And plants get their energy from the sun, and then animals get their energy when they eat or whatever they consume. So these exothermic reactions do not always occur spontaneously. Exothermic, give off energy. So sometimes what they need is an activation energy, and this is the energy that gets the reaction started. So let's look at here. What happens when you have an activation energy present? So on the left here, this is an energy absorbing, so it's endothermic. And here's your reactants at this energy level. Okay, here's your reactants right here at this energy level. And then your products are up here. So that means they absorbed energy. Make sure you see that you look at this graph, because this would be an endothermic. And the one over here is exothermic. And the way you can tell, endothermic ends up with more energy than when they started, and exo ends up with less energy than when it started. So what are the purpose of enzymes then? Basically what enzymes do is they help to speed up the chemical reactions. Okay? And temperature, pH, and other molecules can affect the activity of enzymes. And in your activity you did with your enzyme web quest, you talked about allosteric molecules. Those would be some of the regulatory molecules. So sometimes chemical reactions are too slow, and they're made possible by a catalyst. And so a biological catalyst would be an enzyme. Other things that can speed up the rate of a chemical reaction, you could heat it up, you could stir it, and those would be things that would speed up a reaction also. But enzymes are actual proteins. Remember proteins? Remember one of their things was to increase the rate of chemical reactions? Well, they're also known as biological catalysts. Remember, catalyst speeds things up. And they do this by lowering the activation energy. Okay, now you might want to stop the video and take a look at this diagram or this graph to see what happens. So on the top would be the activation energy required without the enzyme, and then the red line here would be when an enzyme is present, and so it lowers the energy required. So in that example that I gave you earlier with the carbon dioxide, water combines with water and produces that carbonic acid, there's an enzyme in your body called carbonic anhydrase, and it speeds it up 10 million times. It increases it by 10 million. Okay. Now one thing, if you remember, I told you that OSE was sugar, right? Remember that? Well, when you see ASE, that's usually going to be an enzyme. There are some enzymes that don't end with that suffix, but a lot of them do. Many of the ones we'll be talking about this year do. So put that in your back pocket and remember that one. So one thing about biological catalysts is that they're very specific, meaning that carbonic anhydrase only catalyzes that water and carbonic acid reaction, excuse me, carbon dioxide and water reaction. Okay. And they usually kind of go with the name of whatever the reaction they're doing. So we had carbonic anhydrase. Where is it? Here we go. Gets its name because it catalyzes the reaction that removes water from carbonic acid. So anhydrase, anytime you have an, it means remove or the opposite. Okay, so anhydra means water, so it removes water. Now, in order for the enzyme to work, you have what's called a substrate complex, the enzyme substrate complex. And this is a place on the enzyme where the reactants have to meet, or where they have to collide, so that the bonds will be broken and new bonds can be formed. So enzymes help. So in nature, or naturally without the enzyme, they would just, it might take a while for them to hit each other in order for the reaction to happen. But the enzyme provides an exact spot where they can fit that would bring them close together. Okay, in this place where the enzyme substrate complex fits is called the active site. So if you look at this picture here, here's your active site right here. Okay, and that's where the water and carbon dioxide will meet. They fit in there, and so if they do fit in there, like they're moving around and they fit in there, then that reaction is going to go ahead and happen. And that's how an enzyme works. It kind of provides a place for the reaction to happen. So in the enzyme, the substrate binds to a site on the enzyme called the active site. And the site has a complementary shape to the substrate. Remember, the substrates are the reactants. And this theory is called the lock and key theory. And what it is kind of like a lock will only be locked with one key. The same thing with the substrates. They will only fit in one certain active site. Now, things that will affect these enzymes are temperature, pH, and regulatory molecules. I've got on here enzymes generally work best at what temperature? 37 degrees Celsius, and I hope you remember what that temperature is. And they also work best at certain pHs. So if the enzyme is in your stomach and there's acid in your stomach, it probably works better at a lower pH. Now, most enzymes are regulated by molecules that can carry signals within cells, and they can switch the enzymes off and on as needed. So in this picture here, this is kind of a basic diagram. Can you identify the reactants? You see the active site, right? And what's the difference between reactants and substrate? Nothing. Remember, they're the same thing. The active site, and then your products are at the end. So here you go. So see, I've got reactants. Is this maltose? Products are the two glucose molecules. So that means two glucose molecules give you a maltose. And maltose is what type of carbohydrate? That's right, a disaccharide. And the reactants are also the substrate, and then the active site is where the reactants, or where the substrate, can meet. And this ends this video. So I hope this made things a little bit clearer for you. And I will stop here.